Hai, Assalamualaikum dan selamat sejahtera semua. So, in this topic, we will cover on capillary electrophoresis. It's quite a long topic, but we will discuss one by one, and I hope you will get all the information for this topic. So, in capillary electrophoresis, we will divide the course or the topic on introduction, principles, instrumentation, and also application. Dan dalam application kita akan discuss beberapa contoh-contoh secara spesifik how CE is used in forensics. Okay, electrophoresis is actually refers to two terms, electro and phoresis, whereby electro means the energy of electricity and phoresis means force or to carry across. So maksudnya dengan menggunakan elektrik, kita akan carry all the analytes to separate all the analytes. A little bit on the historical part of capillary electrophoresis. It was founded by Arne Tiselius, who lived from 1902 to 1971. He's someone who works a lot with proteins, and at this time, what he's working on is to look at the moving boundary to separate proteins. Okay, and he has won with his work. He has won a Nobel Prize in 1948. Capillary electrophoresis, as you know, is actually one of the separation methods available other than HPLC, GC or IC. Okay, memang tahu kan HPLC apa, GC apa, IC tu apa. Okay, so dalam bidang forensik, usually people will akan utamakan HPLC, GC or IC. CE ni kurang sikit, but with the technology, the advancement of technology nowadays, they are working towards akan lebih prefer use CE lah at certain condition atau at certain cases. For example, macam case gunshot residue, lepas tu kalau minyak-minyak semua dia akan pergi ke GC lah. Tapi kalau macam gunshot residue ataupun benda yang melibatkan ions, very small quantity of analytes, they will prefer to use CE. Okay, why? Because all these things, these are the advantage of CE. First is because CE usually give faster result, good separation. Okay, we can get good separation with CE, and then CE can provide high resolution of separation. Kiranya the resolution tu kita akan nampak dengan jelas dan dapat dikira all the information from the analytes properly lah. But sometimes the resolution ataupun the separation is not stable lah, or low reproducibility. Tapi with you have to have good voltage, good current, and good because it based on current kan, the separation. So you have to have good setup, good current, good parameters before you can do you can get high resolution of separation. And then have large detection, large range of detection methods available. Okay, so detector dia sangat banyak, and then with analyte, kind of analyte yang dia boleh cover ada all the analytes that can be covered using HPLC, GC and IC, but in a very minimum amount. Okay, so analytes yang biasa di cover oleh CE yang boleh digunakan dengan CE ialah neutral analytes, any anions, cations, large molecules, and as you know, it's especially used in DNA analysis. DNA analysis also use this CE modes of instrument. Okay, macam DNA analyzer is also one group of one part salah satu jenis capillary electrophoresis. And another one is because it can cover anion cations, it also can cover enantioselective ataupun analyte yang terdiri daripada campuran racemic. Okay, campuran racemic tahu tak tahu? Okay, campuran racemic ni bermaksud dia ada chiral center, means that dia ada maksudnya dia ada struktur yang sama tapi dalam bentuk 3 dimension dia ada berbeza. Okay, tak apalah, nanti awak boleh search what is chiral compound or racemic compound. Okay, another one, it can apa tu be it is especially prefer by people to do separation because it can run very low cost. First, sebab dia punya distance ataupun capillary tu sangat kecil, so bila kecil dia boleh separate dengan mudah, dan juga bila mudah cepat, so it melibatkan kos kan, kos masa, kos tenaga, kos the electric itself. So that's the main thing lah. After with all these advantages, we come out to one big advantage, which is lower running costs. Okay. Okay, to grab your interest on capillary electrophoresis and how it is used in forensics, I'll just give a brief introduction on how people apply or use CE in forensics. Okay, first, CE is usually used in illicit drug analysis, whereby in 1980, the separation of drug in synthesis mixtures like cocaine, methamphetamine, morphine, heroin, etc. Can be separated because CE is very fast type of separation techniques, and it only involve very small amount of analytes, so that's why it's easy to separate this type of drug. And then the second part is in toxicology. People use toxicology usually in drugs, either in illicit drug again, and also for therapeutic drugs. Or not only about therapeutic and illicit drug itself, but also with its metabolites. They use they use CE in toxicology because toxicology can cover a wide range of biological matrices, for example, in urine, blood, serum, and etc. And one of the use in toxicology is like in toxic and venom, whereby for toxic and venom, usually it is a very complex and unstable polypeptide. So for this type of analyte, we cannot use GC or HPLC because it's not stable, right? Not temperature stable. It can break, and then for HPLC sometimes it's tedious, or it needs a large amount of samples. So usually they use CE for in toxic and venom. Another one in forensic medicines. In modern medicines, they use CE in biological markers for alcohol in blood. Next one is inks. Okay, inks, usually they use CE in document analysis. Of course, inks are, as you know, inks are very complex mixtures of colorants, vehicles, and additives that can produce desired color to write to write on papers. So with CE, we can check on each of the inks to see whether if there is alteration in the inks, in the writings of the document, and we can also check for ink source comparison. Most of the time people use GC and HPLC, but sometimes if it's too small or too small of a difference, we can also use CE to check, especially to check for the aging of various ink samples. And in explosive and gunshot residues, it's quite because in forensic is very particular in explosive and gunshot residues, whereby wide analytical techniques is used. As you know, they also use other techniques like HPLC, GC, SEM, TEM, and others. And one of the analysis techniques that people have explored is using capillary electrophoresis, because with capillary electrophoresis it can covers wide range of organic and inorganic components. So this gives a bit of advantage in CE techniques. And also one of the example is in GSR analysis, whereby CE is very good to separate heavy metals, to look at heavy metals that origin from the primer. So in gunshot residues, people have used capillary electrophoresis to separate or to look at the heavy metals and separate the heavy metals. Okay, and lastly, in miniaturization or lab on a chip, as it named, it can covers all separation techniques, because nowadays people want to do analysis directly, especially at the on-site, right? In forensics, a lot of miniaturization or lab on chips analysis using capillary electrophoresis techniques has been done. So we'll discuss a little bit on this too later. So these are all the 6 techniques, or not techniques, areas that capillary electrophoresis has been used in the area of forensics. So next, we'll focus on what is capillary electrophoresis, the mechanism, and how analyte behave in the CE.